A plastic bucket, half a kilogram of common potatoes, a handful of forest soil, a tablespoon of sea salt, 5 minutes of your time. That is all you need to build a biological factory in your own backyard. A factory that doubles itself every 48 hours, that produces 6 distinct plant hormones at the same time, and that surpasses in measurable performance the bioestimulant products that the garden industry sells in small jars for $30, $40, sometimes $50 per bottle. The global market for biofertilizers reached $3.7 billion in 2024. It is projected to surpass $8 billion by 2030, growing at 14% annually. Each gram of freeze-dried bacteria they sell in those jars costs cents to actually produce. The rest, 85% of the price, pays for packaging, marketing, distribution, and margin. Today, I'm going to show you how to create in your own bucket the homemade version that this $3.7 billion market does not want you to understand. It is not an inferior version. It is the same biology, the same bacteria, the same plant hormones, but alive, active, multiplying in real time. Instead of dead and packaged in a jar that spent 6 months on a distribution truck, if you are the kind of person who believes that real practical knowledge has been quietly pushed aside, subscribe to this channel and hit the bell. We bring you the forgotten wisdom of how civilizations used to feed their own land before the industrial system owned it. 2 parallel stories. To understand why this works, I'm going to tell you 2 parallel stories. One starts in 1965 in a Korean village with a farmer who refused to participate in what the rest of the world was doing. The other starts in 1941 in a laboratory of the United States Department of Agriculture, where 2 researchers noticed something in corn pollen that almost no one believed for 30 years. Neither of the 2 knew the other existed. Neither imagined that 5 decades later their 2 discoveries would meet in a plastic 5-gallon bucket in any backyard, operated by an ordinary person with 5 free minutes and a kitchen knife. And the agricultural chemical industry, which built an entire empire between those 2 discoveries, would prefer that you never learn to make the connection. The Korean farmer village of Swan, Cheongnam Province, South Korea. A young farmer named Cho Han Kyu watched his neighbors slowly destroy their own land. Korea in the 1960s was in the middle of its own green revolution. Synthetic fertilizers imported from Japan and from Western chemical companies were being sold to Korean farmers as the inevitable future of agriculture. During the first years, yields went up, then the land began to fail. The crops became dependent on increasingly larger doses of chemicals. The soil organisms disappeared, the plants weakened, the pressure from diseases increased, and the farms that had fed the same families for 15 generations began to need chemical imports every season just to produce one harvest. Cho Han Kyu refused to participate. Instead of buying what the chemical companies were selling, he turned his attention towards something he had observed as a child. Beneath the leaf litter of any Korean forest without human intervention, the earth was alive, loose, dark, full of white threads, of fungal hyphae and microscopic life. No one had poured fertilizer into that soil, and yet the trees had grown there for centuries without intervention, building their own fertility only with rain, sunlight, fallen leaves, and the activity of microbes beneath the surface. Cho spent the next 30 years asking himself one single, devastating question. If the forest can fertilize itself for free for centuries without anyone adding anything to it, why could a farm not be exactly the same? The answer to that question is what we today call Korean natural farming. But the central idea is simple. Healthy soil is not a mineral substrate. Healthy soil is a living ecosystem dominated by microorganisms. If you collect those microorganisms from a healthy forest soil, multiply them under controlled conditions, and introduce them into your agricultural soil, you can regenerate exactly the same fertility that built the forest from scratch. Cho Han Kyu called those collected microbes indigenous microorganisms. He developed a 5-stage process to capture them, feed them, and stabilize them. The technique spread silently through Korea during the 70s and 80s. By the 90s, his son Cho Young-sang had built upon his father's work a simpler, faster, more scalable version. He called it JADAM, a Korean acronym that translates roughly as people who resemble nature. The flagship product of the JADAM system is the Microbial Solution, JMS. While his father's original process required 5 stages over several weeks, Cho Young-sang demonstrated that you could cultivate a similar microbial population in a single bucket in 2 or 3 days. And here is the moment that defines this entire story. Cho Young-sang gave everything away. He never patented the recipe. He published the complete method in books and on a free website that today is used by more than 100,000 farmers in Korea, Africa, Asia, and America. The site jadam.kr has conference videos, exact recipes, and field trial data covering every globally important crop. Cho Han Kyu died in 2021 after spending 6 decades teaching farmers in more than 30 countries how to make their own inputs. He never patented a single technique. He never accepted royalties. He published everything. His son continues that work today. But the Korean story by itself does not explain why a bucket of fermented potato scientifically surpasses a $50 jar. For that, you have to cross the ocean to a United States Department of Agriculture laboratory where in 1941 2 researchers noticed something in corn pollen that almost no one believed for 3 decades. Hit the like button if this is hitting something inside you. It takes 1 second, but it helps families who deserve to hear what was hidden from them. The American Discovery, Beltsville, Maryland. Year 1941. 2 American researchers, J.W. Mitchell and M.R. Whitehead, published an article in the journal Botanical Gazette. They described something they had observed when extracting compounds from corn pollen and applying them to other plant tissues. Those tissues grew dramatically. The effect was reproducible. The mechanism was unknown. The article was practically ignored for almost 30 years. Until in 1970, Mitchell returned to the question. This time, his team extracted oily compounds from canola pollen and applied them to pinto bean seedlings. The growth response was not subtle. The stems elongated rapidly. Cell division accelerated. The compounds made the plants grow in ways that the plant hormones known at that time, auxins and gibberellins, could not explain. They called that new family of compounds brassins. They published it in the journal Nature in 1979. After processing more than 230 kilograms of canola pollen collected by bees to extract barely 4 milligrams of pure compound, the team finally crystallized the most active member of the family. They called it brassinosteroid. X-ray crystallography revealed something astonishing. Brassinosteroid was a steroid, a real plant steroid structurally similar to the steroidal hormones of the animal body. Plants had their own steroidal hormones. They had always had them, and no one in 200 years of botanical science had noticed them. Brassinosteroids are today recognized as the 6th class of plant hormones. They control cell elongation, cell division, photosynthesis, vascular development, seed germination, fruit yield, and resistance to practically any form of biotic or abiotic stress. They act at concentrations of parts per billion. They are produced naturally in every plant on Earth, in the pollen, in the seeds, in the roots, and in the young growing tissue. Where the stories collide. Here is where the 2 stories collide. The microorganisms that Cho Han Kyu collected from the Korean soil, the same ones that multiply inside a JMS bucket every 48 hours. They are not simple, generic decomposers. A massive amount of peer-reviewed research, published in journals like Frontiers in Plant Science, Plants MDPI, BMC Plant Biology, and the Journal of Plant Interactions, has documented exactly what those microbes do. They produce hormones, specific bacterial genera that dominate forest soil and proliferate inside JMS buckets, including Bacillus, Pseudomonas, Azospirillum, Serratia, Stenotrophomonas, and Arthrobacter have been confirmed as producers of plant phytohormones as part of their normal metabolism. A 2024 review titled Biosolutions for Green Agriculture, published in the National Library of Medicine database, details the complete chemistry. These bacteria produce indole acetic acid, the master auxin that controls root growth. They produce cytokinins, the hormones responsible for cell division. They produce gibberellins, the hormones that control stem elongation and germination. They produce an enzyme that breaks down ethylene and protects the plants from stress. That is not theory. That is the difference between a tomato stem that breaks with the first gust of wind and a stem as thick as your thumb. It is the difference between timid white roots that barely cling to the soil and a root system so dense that when you pull the plant, it comes out with a complete cylinder of soil attached. It is the difference between a squash the size of a baseball and one the size of a football, on the same plant, the same year, with the same seed, and here comes the part that almost no one outside of specialized microbiology has heard. Some of these soil bacteria also produce compounds with activity similar to brassinosteroids, the same family of plant steroids that the United States Department of Agriculture took 40 years to identify. The microbes were producing them all the time. They had been producing them in every healthy forest soil on Earth for hundreds of millions of years before any scientist put a name to a single molecule. The bioreactor in your backyard. When you prepare a bucket of JMS, you are not simply mixing water with potato. You are building a microbial bioreactor. You provide a starch source, the potato. You provide a mineral source and an osmotic stabilizer, the sea salt. You provide a mixed population of microorganisms, the forest leaf mold. And you provide water and a partially anaerobic environment, the bucket. In the first 24 hours, the dominant aerobic bacteria, mainly Bacillus species, begin to multiply explosively. By 48 hours, the population has doubled at least once, frequently several times depending on the temperature. By 72 hours, the culture shifts to a facultative anaerobic state, where lactic bacteria and other fermentative organisms begin to dominate. And throughout this entire cascade, those bacteria synthesize phytohormones at a speed hundreds of times greater than they would produce in static soil. When you pour the resulting liquid into your garden, you are not adding water. You are adding a hormonal cocktail that includes auxins, cytokinins, brassinosteroid analogs, vitamins, organic acids, and a living population of beneficial microbes that immediately begin to colonize your soil and continue producing hormones on site for weeks afterward. Why the industry cannot replicate this? There is not a single commercial product on Earth that delivers all these compounds simultaneously at this concentration in living and biologically active form. The reason is not scientific, it is structural. A living bacterial culture cannot be bottled and shipped without continuous refrigeration, special packaging, and aggressive expiration dates. The same chemistry that makes JMS so potent is the chemistry that makes it commercially impossible to mass produce as a stable shelf product. That is why the industry instead sells you single freeze-dried strains in jars, dead strains, strains reactivated with luck when they arrive at your soil. While a JMS bucket gives you a living, diverse, synergistic community in full multiplication. The difference is not theoretical. It is the difference between a soldier and an organized army. But the best part of this system is not what the bucket produces in the first 48 hours. The best part is what you are going to learn at the end of the recipe. A single walk to the forest, a single time in your life, can give you infinite fertilizer for the rest of your life as a farmer. It is a propagation trick that the commercial industry structurally cannot imitate. And it starts with 4 materials that you probably already have at home. Phase 1. The collection. 4 materials, 5 minutes of collection, everything you need to start. First, a standard plastic 5-gallon bucket, approximately 20 liters. Any hardware store, any garden store, any clean paint bucket works. Second, 15 liters of clean water without chlorine. Rainwater is ideal. Well water works. Filtered water also works. If you only have chlorinated tap water, leave it uncovered in the sun for 24 hours before using it. The chlorine evaporates on its own. Third, half a kilogram of common white potatoes. 2 or 3 medium potatoes. Wash them but do not peel them. The skin has starches, minerals, and additional beneficial microorganisms that you do not want to throw away. Fourth, and the most important, a cup or 2 at most of forest leaf mold. Walk to the nearest forest or grove without human intervention. Move aside the top layer of fallen leaves, dig down 5 to 10 centimeters toward that dark, crumbly soil full of white hyphae that you will see if you look closely. When you sink your hand into that soil and lift it up, you're going to feel something specific. It is cold, even in the middle of summer. It is damp, but not wet. and it gives off a smell that does not resemble any other smell. Sweet, earthy, almost like fresh cheese. That smell is the chemical signature of the microorganisms you're about to harvest. The human nose, without knowing it, can detect the presence of these bacteria long before any microscope confirms them. If you live in an urban area without accessible forest, the oldest and darkest compost you have available works as a second option. Worm compost from a well-established worm bin works as a third. They are not identical to forest mold, but the process starts. And one more, almost at the end but equally critical. 2 tablespoons of unrefined sea salt, not table salt, not iodized salt, sea salt or rock salt of the type that still contains trace minerals. The salt provides minerals, regulates osmotic pressure, and selectively favors the growth of beneficial microbes over harmful ones at this concentration. That is all the collection. 5 materials, 5 minutes. Phase 2. Assembly and the 2 fatal errors. Before mixing anything, listen to this. There are 2 errors that kill the bacteria before they have the opportunity to start multiplying. Commit either one of the 2 and your bucket will not produce anything useful. Fatal error number 1, using a metal bucket. Metal interferes with microbial activity. It corrodes in the slightly acidic environment of fermentation, and it releases ions that kill part of the bacterial community. Only plastic, glass, or ceramic work. Fatal error number 2, using chlorinated water directly from the tap. Chlorine was specifically designed 100 years ago to kill bacteria in drinking water. It is going to do exactly the same thing inside your bucket. It kills the microbial community in the first hours before it has the chance to establish itself. If you avoid those 2 errors, the rest is almost impossible to ruin. For the assembly itself, cut the potatoes into pieces and boil them in approximately 2 liters of water for 20 to 30 minutes until they are soft enough to mash with a fork. The potato starch is the carbohydrate fuel on which the microbes are going to multiply. The boiled water becomes a broth rich in starch. Take a pair of clean cotton socks or a piece of gauze-type cloth. Place the boiled potatoes inside one sock, tying the end. Place the handful of forest soil inside another. Submerge both little bags inside the bucket filled with the 15 liters of water without chlorine. Add the sea salt. Stir everything. Put the bucket somewhere with shade, ideally between 15 and 30 degrees Celsius. If you live where temperatures drop below 15 degrees, take it to a basement, garage, or any enclosed space where the temperature remains stable. Below 15 degrees, the fermentation slows dramatically. Below 0, the entire culture dies. In very hot tropical climates, add a tablespoon of brown sugar or molasses to accelerate the initial explosion. Cover the bucket with a loose cloth or a lid resting on top, but do not seal it hermetically. The fermentation produces gas, and if you seal it, the bucket can deform or burst. At 12 hours, the bacterial population begins to multiply silently. At 24 hours, you will see foam forming on the surface. At 48 hours, that foam will be thick, dense, visibly bubbling, almost like bread dough rising. That foam is the visual indicator that the colony reached its first major exponential phase. At 72 hours, the brew is fully active and ready to use. In warmer climates, it can be ready at 48. In cold climates, it can take up to 4 days. To use it, dilute 1 part of JMS in 10 parts of water. Apply it as irrigation to the soil around the base of the plants, once every 2 or 3 weeks for maintenance, weekly if you are regenerating severely degraded soil. A safety note before the last step. The sea salt is essential, but only in the specified proportion. Excessive salt kills the microbes and damages the soil if applied repeatedly. Always dilute 1 to 10 before applying. Never use iodized salt. Never apply undiluted JMS directly on young plants less than 2 weeks old. And if you have concerns about pathogens, particularly if you are using compost instead of forest soil, let the complete 72-hour cycle run. The lactic environment that develops during fermentation suppresses most pathogenic organisms. Phase 3. The infinite loop. And here is the part I promised you at the end of the previous act. The part that the commercial industry structurally cannot imitate. A single bucket of finished JMS can be used to start an unlimited number of new buckets. Take half a cup of the finished JMS and add it to a fresh bucket of water, potato, and salt. You skip the forest mold step entirely after the first bucket. The microbial colony is now self-propagating. That is the absolute structural difference between your bucket and any commercial product. Infinite multiplication. A single walk to the forest, a single time in your life as a farmer, is enough for you to produce hundreds of liters of biofertilizer during the current season and during all future seasons. Every time you empty a bucket, you simply save half a cup to inoculate the next. The industry sells you a jar that runs out. Your bucket, once started, never runs out. The finished JMS lasts approximately 2 to 3 weeks at room temperature before the population shifts toward anaerobic putrefaction and develops an unpleasant smell. It does not have a long expiration date because it is not a shelf product. You make it, you use it, you make more. That is the complete system. Comment below if you have heard of Korean natural farming or JADAM before this video, or if this is your first time hearing the names of Cho Han Kyu and his son, Cho Young-sang. I'm curious to know how far this knowledge has spread. The liberation of knowledge. 60 years ago, Cho Han Kyu refused to participate in what the chemical corporations were telling him was the inevitable future of agriculture. Instead of buying fertilizer in a bag, he looked beneath the leaf litter of a Korean forest. He spent 30 years deciphering what he saw, and then he gave away every technique he developed. No patents, no royalties, retaining nothing for himself. His son continues publishing everything for free. The recipes are free, the conferences are free, the videos are translated into English, Spanish, Portuguese, French, Swahili, Tagalog, and a growing number of other languages. The knowledge is being released to the world deliberately, against the gravitational force of the commercial system that would prefer to keep it locked behind brand packaging. Meanwhile, every jar of commercial biostimulant sold contains bacteria that originally came from a forest soil similar to the one you have near your house, bacteria that were already free, bacteria that were multiplying on their own for hundreds of millions of years before any corporation discovered them, pasteurized them, packaged them, and sold them back to you. Each one of those consumers is paying without knowing it for something that nature was willing to give them for free from the beginning. But the bucket disproves it every 48 hours. The foam rises, the colony doubles. The plant hormones synthesize at a speed hundreds of times greater than in static soil, and all of that happens without a patent, without a label, without a barcode, without a monthly invoice to a company that had never heard the name of your town before selling you its product. The bigger pattern. This is not the only story like this. The same pattern repeats with fermented plant juice, with fish amino acids, with lactic bacteria serum, with oriental herbal nutrients. The greater part of the complete modern regenerative agriculture kit was developed and refined in Korea, Japan, India, and the Philippines. Decades before Western agriculture even recognized that soil biology mattered. The knowledge was never hidden. It simply was not translated. Today it is. Today you are listening to this research in English, in your language, in your house, without paying anyone for the privilege. That in itself is a silent way of reversing 70 years of misinformation. The final question. The question I leave you with is this. Your next harvest, your next garden, your next year of food production on your land. Are you going to feed it with a jar that you bought, or with a bucket that you multiplied yourself? Are you going to hand that money to a corporation that extracted its bacteria from the same forest that you can walk to tomorrow? Or are you going to walk to the forest yourself? You do not have to set up 5 buckets the first month. Start with 1. Spend half an hour walking to the forest, another half hour making the bucket, wait 72 hours. Apply the first dilution to a single plant as a test. Compare the result after 3 weeks with a neighboring plant that received nothing. When you see the difference, you will not need me to convince you of anything. If this research changed the way you see the biofertilizer jars you have seen 1,000 times at the agricultural store without knowing what they were, drop me a comment below. I want to know what region you are from, what type of forest or grove you have near you as a source of inoculant, and whether you are going to try it this month. Subscribe to the channel where we keep unearthing the systems that almost made us forget. See you in the next one.